Hi, everyone. My name is Amy Woods, and I'm going to be presenting on masonry facade repair and restoration priorities for adaptive reuse. So, one of the main things that why this is so important is that before you do any adaptive reuse project, you have to consider the building's envelope, its roofs, and its facades, especially if it's historic facades, because you certainly don't want water leakage or things falling off of buildings. So let's start with masonry facade wall systems. There's either mass masonry walls. This has been going on for thousands of years, and it can be multiple wides of brick or stone or combinations thereof. And in essence, it is primarily all load bearing and all somewhat moves together uniformly. Then you have transitional masonry. This is the mid to late 1800s, where we start to integrate steel as also a load bearing form of the structure. And oftentimes, this steel is right adjacent to the masonry materials, whether it's brick, hollow clay tile, cast stone, terracotta, stone. So, one of the main issues is that there's a lack of movement joints because the masonry materials and the steel do move differently. And those lack of movement joints in older construction can be problematic. Barrier walls, these are primarily things like exterior clad thin dimension stone with anchors back to the structure. And then we have cavity walls. Again, these are a cladding system that's anchored back to some other structure, but there's an air cavity in between it, likely with flashing systems. So the reason this is important is because it's very important to understand these different wall systems. Mass masonry relies, it's very thick, and it relies on vapor transmission and breathability through this multiple wise of masonry to be able to allow some water in and dry out. Things that limit that are lack of maintenance, water infiltration from horizontal surfaces, inhibiting that breathability, such as putting coatings or sealers on the exterior, the wrong mortar joints, which are trapping up all your masonry mortar joints, or even the wrong type of interior insulation. Trapping moisture in these walls can lead to their demise. Transitional masonry buildings, water gets in, you've lost that thickness, you've lost some of that breathability, and in essence, that steel can corrode. That corrosion is expansive and then is damaging to the masonry materials. So this is one of the most vulnerable types of wall systems out there, and we end up doing a lot of repair and restoration work on these types of walls. Barrier walls were originally intended not to allow any water in. We know that's not true. So these have a high level of maintenance as well. And then cavity walls were designed to allow a little bit of residual water in and then getting that water back out through proper flashing systems. The most vulnerable part of any facade are those horizontal skyward facing surfaces. Things like cornices, parapets, belt courses, water tables, and windowsills. They are all like little mini roofs all over the building. If there is an opening on one of those horizontal surfaces, a debonded mortar joint, a debonded sealant joint, water can directly get in and it goes directly into the wall system. So it's a big deal to make sure those are protected. The next thing that's on our list is material properties. In addition to knowing what type of wall system, it's important to understand what masonry materials are used on your project and make sure that the goal of the project is with repair and replacement that we match as closely as possible to those properties. We also want to not limit that breathability of the wall. So in this example that I'm showing you, this Chicago Common brick has been painted. There's a silane sealer on it to top it off. And there's a very hard, dense mortar smear coat all over it. All the most wrong things you can possibly do. We have a lot of different masonry materials: stone, brick, terracotta, cast stone. All of these materials have different strengths, different densities and porosities, and different water absorption. We'll take a look quickly at each one of these. Stone is a naturally forming material. It can be hard like a granite, And it can have other different properties, and it can also have veining, fissures, secondary minerals. So it's not always uniform, and they can vary widely amongst these different stones. Our friends in Scotland, they take this very seriously. They're probably the renowned research on conservation of stone, and they look at microscopy and thin section analysis to make sure that when they're putting a new stone into a building for repair or replacement, that it matches as closely as possible at the microstructure. If we do not, we could have examples like these. The replacement stones in these examples are way too hard and too dense. And what happens when that occurs is that as these stone facades weather, it diverts the water from the dense areas and puts them onto, at a higher rate, into those stones that are weaker or more porous. So they will cause accelerated damage to its original materials. Brick are clay-based materials. Again, they have things like sand and grog in them, secondary minerals. These are softer, tend to have expansive qualities due to the clay. But one of the natural forming things on brick is their fire skin that is developed in the kilns. That fire skin is slightly more dense than the interior body, which allows it to have lower water absorption in comparison to the interior body, which typically has a little higher water absorption. This means protect that fire skin at all costs because it's the naturally protective part of the building. So no acid washing, no abrasive cleaning, no things that would damage that inherent natural protective skin. With brick, there are a lot of different variables to its color and texture. And when you're trying to find replacements, you need to look at what the age of the existing brick is, what its sizes are, how it was originally produced, because the new brick, those raw materials in it, the manufacturing process of how it was pressed, is it hand pressed? Is it mechanically pressed? Is it machine pressed? What's the form of finishing? Is it extruded? All of these things play a role in these brick, in addition to the kiln temperature for its color as well. Terracotta, also a clay masonry material. It typically has more refined clay and materials than a brick, but still includes sands, grog, things like that, and also typically, although not always, has a glaze coating on it. In very generic terms, terracotta is typically very dense and strong in comparison to its cousin, the brick, but that's not always the case, certainly compared to modern brick. Mortars are so critical. I've seen so many damaged buildings due to the wrong mortar being put in. On the left, we have an 1850s soft pressed, very porous brick, and the original mortar was a hot lime mix. So we need to go back with a softer mortar. On the right, it's a very hard, dense granite. A more modern Portland cement based mortar may very well be appropriate for that one. So you have to be mindful, because if you use the wrong mortar or wrong type of mortar that's too hard and too dense for that masonry material, you will cause premature damage. So it's really important when you're going through these priorities, and obviously in our short time, we won't have time to cover everything affiliated with a repair and restoration project. But a couple of key important things I want to go over is one, the vulnerable parts of a building are those horizontal surfaces. So let's first off get those protected. And then when we have transitional masonry buildings, again with steel, we want to try to improve some of that water management so it will be longer lasting. Then we want to make sure we select materials that are appropriate and compatible with the original. So first, protecting those horizontal surfaces. It can be with sealant, silicone sheet, lead T-caps, or things like that. And again, these are probably in the realm of 20 years plus or minus as far as longevity. On the upper left is a reinforced roofing membrane material. This again could be applied where you have a lot of undulations, and you can get about 40 years plus or minus on that. Want more durability? A sheet metal product such as coppers, leads. There's also stainless steel, galvanized, anodized aluminum. These are all in that 70 to 100-year range, if not more, for some of these materials. And then lastly, especially if you're working on unreinforced mass masonry buildings where there's no reinforcing, and let's say you have a project where you need to go in and seismically update them or even secure those parapets, please integrate durability with the structural stabilization. Get some through wall flashing in there. In this particular case, they've put thimbles that are soldered on the tops of those anchors to make sure that the anchors are not breaching that waterproofing membrane. So an excellent, probably well over 100-year solution there. When you're opening up parts of a building that are susceptible to damage, window lintels, shelf angles, bottom flanges of beams, let's improve the water management, integrate new flashing systems, make sure to get those end dams in there, drip edges, all of the components that are important for flashings to improve that water management. So I'll showcase a few adaptive reuse case studies in the Chicago area. We will start with a warehouse, which is actually where I happen to live. So if you can kind of see my background, I have a big concrete column behind me. But this was constructed, it's a brick masonry and concrete mass masonry building built in 1929. It was converted to condos in 1995. I have lived here about 2 years. There's no historic landmark status with this particular building. And so some of the work on here was less than ideal. So some of the distress is that the brick was painted on the back side. There was a silane coating put on the front facing brick. The wrong mortars have been used repeatedly through the years, too hard and too dense. So lots of areas on this building where water is being trapped, not allowed to get back out and causing damage. We can see efflorescence and scaling of some of the interior faces of the brick. We also can see that the sealant joints have not been well maintained on horizontal surfaces, windowsills, leading to additional water infiltration. So during repairs, you need to deal with the system. You've got to put flashing systems in above these windows. We've got to make sure that those perimeter sealants around the windows are maintained and sealant joints in the top sides of the window sills are maintained. They have to be protected. These are some examples of a new roofing, but where a lot of those sealants are not done ideally, like they're not put in a great location and they're not lasting. The brick materials have to be compatible, whether it's stone or brick. And again, putting a coating on brick is a no-no. Putting too hard and too dense of mortar is really causing a lot of damage. And just to get a little bit of a peek inside, this happens to be my unit. We've got 57 units in this building. Old Cook County Hospital, this was a building that's terracotta. This is a transitional masonry building. There's also brick on this building, constructed starting in 1912. It started being vacant in 2000, so was vacant for 22 years. This is a landmark building, both in the city of Chicago and on the National Register. So adaptive reuse turned this into a beautiful hotel as part of a whole community revitalization. Walsh Construction was the general contractor, WJE the facade engineer. A lot of the conditions were water's getting in, that steel is corroding, causing a lot of damage. A lot of that terracotta has lots of cracking and spalling and a very unsafe condition. So a lot of the repairs start with those systems, repairing or replacing the steel, rebuilding back areas of soffits and parapets and windowsills that had been damaged, and then making sure that when we put the install back, that those areas that are horizontal facing are protected with a waterproofing membrane, selecting materials that are appropriate and similar and compatible to the original terracotta. And in this case, they did put some insulation on the interior of the walls. Again, you have to make sure that there's no water management or there is water management on the exterior facade before doing this, because some of these insulations can trap some moisture. And this is a project video from that project.
For decades, this was the largest public health facility in North America. When this old building was closed up, it stayed closed and boarded up for 18 years.
This was a very scary looking building.
You literally could not walk through the corridor without touching lead paint that had curled off the wall. 5 layers of ceilings were down on the ground. you were not walking on the ground. You were walking on 1913 construction, 1940 construction, 1970 construction.
Looked like a scene from a horror movie.
It was ready for demolition. We've got the opportunity to rebuild that community. It's called Harrison Square.
We hope to build approximately 3 million square feet of space.
When we put up our construction fences and started this project, you could just feel the life coming back into this neighborhood.
Just seeing the building under construction has just been a great thing for the area.
We're ordering approximately 4,000 pieces of terracotta. My goal on this project is to fully restore all of the terracotta that has been removed or has been damaged, and to make it blend in so that it never looked like we touched the facade at all.
This is the progress you're really going to see and notice. The training, the quality is absolutely world class.
We're like family. I had my son here in 1989.
Being born here on the 5th floor of the maternity ward, God has blessed me to come back again 52 years later.
You're going to see an energy level brought to this location that's not been seen since the building opened originally at the turn of the century.
To renovate a building like this is really to touch a part of history.
Cook County is one of the largest and most ornate examples of classical revival public building in the city. There were so many times that people thought it was coming down. To see it be saved and rehabilitated is always gratifying.
I'm actually going to come here and stay in one of the rooms just because, you know, I helped build this.
There'll be apartment buildings, there'll be condominium buildings, grocery stores, commercial spaces.
We're going to look to employ thousands of people over the next 10 years.
To be a brick in the building, be a part of the building for the next so many years, 100 years, will be a blessing.
And so the next project I want to go over is the old post office. This is a gigantic structure. It's been abandoned for, I think, 24 plus years. Constructed in 1924. This is limestone with steel elements and steel shelf angles in it. Again, this one happens to be a Chicago City landmark and a National Register of Historic Places. The restoration occurred in 2021. The general contractor was Bear Construction with WJE as the facade engineers. So again, a lot of that steel that's behind the scenes is causing havoc. If water infiltration gets in there, it corrodes and causes distress, cracking, spalling. Sometimes you can't always see that. So the repair is to go in there and take care of the corroded steel, make sure that you're protecting those horizontal surfaces from water infiltration and selecting stone replacement materials for either Dutchman repair or full stone repairs that are compatible, same material, same properties. And here is a video by Bear Construction on that project. So those are some examples of some adaptive reuse projects in Chicago, and you cannot start an adaptive reuse project without that facade restoration and making sure you address some of those critical, important aspects of facade restoration. So thank you so much for having me. Enjoy the rest of the conference.